Nuclear power is one of the most misunderstood energy sources in the world. For some, it's a marvel of modern science, producing enormous amounts of electricity with minimal carbon emissions. For others, it's shrouded in fear thanks to infamous disasters like Chernobyl and Fukushima. But what actually happens inside a nuclear reactor? How does it generate the electricity that powers our homes, factories, and cities? In today's video, we'll break down the science step by step and explain what goes on inside the heart of a nuclear reactor. A nuclear reactor is a device designed to harness the energy released during nuclear fission. Fission is a process where the nucleus of a heavy atom, typically uranium-235 or plutonium-239, is split into smaller nuclei, releasing a massive amount of energy in the form of heat and radiation. This heat is used to produce steam, which drives turbines to generate electricity. Think of it as a high-tech steam engine, but instead of burning coal or gas, it uses the energy locked inside atoms. To understand what happens inside, let's look at the key components of a nuclear reactor. 1. Fuel rods. These are filled with pellets of enriched uranium or plutonium. The fission process begins here. 2. Control rods, made of materials like boron or cadmium. These rods absorb neutrons. By inserting or withdrawing them, operators can control the rate of the reaction. 3. Moderator. This is usually water, heavy water, or graphite. It slows down the neutrons produced during fission, making it easier for them to split more atoms. 4. Coolant, typically water or a gas. The coolant carries away the heat produced in the reactor core. 5. Containment structure. A thick reinforced concrete and steel dome surrounds the reactor to prevent radiation from escaping. Each of these components plays a crucial role in keeping the reactor safe and efficient. The heart of a nuclear reactor is the fuel rods, where nuclear fission occurs. When a neutron strikes a uranium-235 nucleus, the atom splits into smaller nuclei like krypton and barium. This process releases 1. Heat energy. This heats up the reactor's coolant. 2. Neutrons. These go on to trigger more fission reactions in a chain reaction. 3. Radiation. Gamma rays and other particles are released as a byproduct. This chain reaction needs to be carefully controlled to prevent overheating or a meltdown, which is why control rods are so important. The heat generated by fission is absorbed by the coolant, which typically flows through the reactor core. Most modern reactors use water as both a coolant and a moderator. The coolant gets incredibly hot, up to 300 degrees Celsius, but doesn't boil because it's kept under high pressure in pressurized water reactors, the most common type of reactor in the world. In the next step, the superheated coolant passes through a heat exchanger or steam generator. Here, the heat is transferred to a separate loop of water, which turns into steam. This steam is then used to spin massive turbines, which are connected to generators. The spinning turbines produce electricity, which is sent out to the power grid. What's remarkable is how efficient this process is. A single pellet of uranium fuel, about the size of a gummy bear, can produce as much energy as a ton of coal or 150 gallons of oil. Safety is the top priority in any nuclear reactor. Modern reactors are equipped with multiple layers of protection to prevent accidents. The first is control rods can instantly shut down the reaction by absorbing excess neutrons. Secondly, it has emergency cooling systems that kick in to prevent overheating if the primary coolant system fails. And the other is containment structures that ensure, even in the worst-case scenario, radioactive materials don't escape into the environment. Additionally, reactors are designed to operate within strict safety margins, and they undergo regular inspections and maintenance. There are several types of nuclear reactors in use today. 1. Pressurized water reactors, PWR. The coolant is kept under pressure to prevent boiling. 2. Boiling water reactors, BWR. The coolant boils inside the reactor to produce steam directly. 3. Advanced reactors. These include small modular reactors, SMRs, and fast breeder reactors, which are more efficient and produce less waste. Each design has its own advantages, but all follow the same basic principle, using fission to generate heat and electricity. One of the biggest challenges of nuclear power is dealing with radioactive waste. Spent fuel rods are highly radioactive and must be carefully stored. Initially, they are kept in cooling pools for several years to allow the radiation to decay. After that, they're transferred to dry cask storage or, in some cases, reprocessed to extract usable materials. While managing nuclear waste is a challenge, advancements in technology are making it safer and more sustainable. Nuclear power has its pros and cons, but it's undeniably one of the most efficient and reliable sources of energy we have. It produces zero greenhouse gases during operation, making it a key player in the fight against climate change. With proper safety measures and advancements in technology, nuclear power could play an even greater role in our energy future. So that's what happens inside a nuclear reactor, a marvel of engineering that turns the energy of atoms into electricity for millions of people. What do you think about nuclear power? Let me know in the comments below. And don't forget to like, subscribe, and hit the bell icon for more fascinating science content. Thanks for watching.